Okay, so now we're going to look at arithmetic and geometric sequences. Now, if you didn't like trying to do the general term before, this really should kind of help you. Okay, this kind of gives a rhyme or a reason, a formula, if you will, for, actually it has a formula, for writing general terms. So, if you didn't like having to just figure it out, this should really help you, I think. So, in arithmetic, and you're going to hear that said many different ways, that's the way I say it. Okay, it's an arithmetic sequence. Some people call it arithmetic sequence. Okay, I call it arithmetic. I don't really know what the proper way is. I suppose I could look it up, but I haven't. So, I'm going with arithmetic sequence, and it is a sequence in which each term differs from the preceding term by a constant amount d. Okay, the constant d is called the common difference. That's why it's a d. Common difference of the sequence. Okay, so d is going to be the common difference. So, for example, okay, when I'm looking at something like this, first of all, 2, 6, 10, 14, 18. Hopefully you can look at that and recognize that pattern. So 2 to 6 is 4, 6 to 10 is 4, 10 to 14 is 4. So we're increasing by 4 each time. So the first term, a sub 1, is really just the first term in the thing, so it's going to be 2. Okay, the common difference here is going to be that number it's increasing by, which is 4. Now, write the first 5 terms of the, I'm going to show you what to do with these in a minute. So, write the first 5 terms of the arithmetic sequence whose first term is 7 and whose common difference is 2. Okay, so whose common difference is 2. So they give us that the first term here is 7, and they also give us that our common difference is going to be 2. So what that means is for the first term, we start at 7, literally. For the second term, since the common difference is 2, I would do 7 plus 2, which would be 9. To get to the third one, okay, I don't do 7 plus 2 and get 9 again. The numbers aren't going to repeat. I start from here, so I'm going to get 9 plus 2, which is 11. Fourth term, 11 plus 2, which is now 13. And fifth term is going to be 13 plus 2, which is 15. Okay, so that would be my 5 terms, 7, 9, 11, 13, and 15. 7, 9, 11, 13, and 15. That would be my first 5 terms. Okay, so I told you this is going to help you. Well, it is, because there's going to be an equation that you can memorize. Okay, the general term a sub n of an arithmetic sequence, arithmetic meaning that it has an increase by adding or subtracting, okay, is given by the general term is equal to a sub 1 plus n minus 1 times d, where a sub 1 is the first term and d is the common difference. Okay, so the n minus 1 happens because the difference, when you go to do the difference, we don't want to add anything to the first one, so we're going to subtract, so we get 0, so we don't add anything to the first one. And then after that, it'll add one set of the common difference, 2, 3, 4, and so on and so forth. Okay, so let's take a look at one of these. Consider the arithmetic sequence. They tell you it's arithmetic, that's important, whose first term is 3 and common difference is negative 5. Okay, it can be a negative common difference. So, write an expression for the general term a sub n. Well, we're just going to plug it in. Since it's arithmetic, a sub n is going to be a sub 1. Let me write this here for you. A sub 1 plus n minus 1 times d. Okay, so I know that my first term, which is a sub 1, is 3. My common difference, which is d, is going to be negative 5. So plus n minus 1 times 5. Okay, now I'm not going to leave it like that. I'm going to multiply this out. So a sub n is 3 plus 5n minus 5, because I would have to distribute here. Okay, n times 5 and negative 1 times 5. So that would give me Oh, see, and I almost made a mistake here. The D they said was negative 5. So sorry. D they said was negative 5, not positive 5. Which means that when I multiply, okay, I would get negative 5n and positive 5. Okay, negative, because I'm going to multiply still, negative 5n and positive 5. And that was because that D was negative 5. Sorry about that. Okay, so then I just put those like terms together. 3 plus 5 is 8, so I get 8 minus 5n. And that would be my, I'm all over the place, that would be my a sub n. So a sub n is 8 minus 5n. Okay, that makes it a little bit easier, because if I was trying to just figure that out, I could write out my first 5 terms or so and try to find the pattern and write it out. But that's going to be a lot harder to figure out that I had to start with 8 and subtract 5n from. Okay, the stuff we did on the very first day, they were really simple, really easy numbers. They were just multiplying by 2 or 3. Okay, these are a little bit bigger and a little bit more difficult, so it's definitely good to have a formula to work with. So B, find the 20th term of this sequence. So that's for sure. Okay, now I have the 20th term. I really want to have that general term. So now, since I have a general, a sub n is 8 minus 5n, I find the 20th by just plugging in 20. Okay, and that we did do on the first day, so 8 minus 5 times 20. Okay, so that's going to be 8 minus 100, which means that a sub 20 is negative 92. Okay, so the 20th term there is going to be a negative 92. So I've got my general term, and then I can use that to find any other term. Okay, so on your own, I highly suggest you give this a shot before we move on to geometric sequences. Okay, try this. Consider the arithmetic sequence whose first term is 2, whose common difference is negative 3. See if you can't use that formula and find your general term and then the 12th term. Okay? So hit pause. Hopefully you're coming back right now. I'm going to go ahead and start plugging stuff in. So here's my formula. A sub 1 plus n minus 1 times d. Okay, so take that and start plugging stuff in. I have an a1 value that's 2. And I have a difference of negative 3. So a sub n, a sub 1 is 2, plus n minus 1 times d is negative 3. Okay, so I'm going to distribute, so we're going to get 2 plus n times negative 3 is negative 3n, so I can do it minus instead of plus. So minus 3n, and negative 1 times negative 3 is positive 3. Okay, so final answer here, a sub n, 2 plus 3 is 5, minus 3n. So that should be my general term. And then I want to find the 12th term of the sequence. So to find the 12th term of the sequence, you just plug in 12. So a sub 12 is 5 minus 3 times 12. Okay, 3 times 12, 12, 24, 36. It's 5 minus 36, so a sub 12 is going to equal to negative 31. Okay, I hope you got those right. If not, you can always go back and try them again. Okay, write down just the problem and try them again. See if you can't get the correct answer the second time. Okay, that will help you. If you do these things over and over again, you'll start to see the patterns. It really will help. All right, so on example 3, find the 11th term of the arithmetic sequence whose first 3 terms are 2, 9, and 16. Okay, they tell us it's arithmetic. That's very nice of them. We know that it's increasing by either adding or subtracting. So 2, 9, 16. So from 2 to 9, it went plus 7. 9 to 16, plus 7. I know it should be increasing by the same number all the way across because they said it's arithmetic. So find the 11th term. Well, I'm not going to do 11 terms adding 7 every time. I'm going to find my general term. Okay, so if I find my general term, here's my A1, A2, A3. My general term, I'm going to plug it in. So A sub n is equal to A1, okay, plus n minus 1 times d. Still using the exact same formula. Okay, well, A1 is my first one, so it's 2. And my D value is the change, so it's plus 7, so there's D. Plug that stuff in. A sub n is going to be 2 plus n minus 1 times 7. Okay, so 2 plus distribute 7n minus 7. So I get negative 5 plus 7n. You can put the 7n first, that doesn't matter. I can do 7n minus 5 or minus 5 plus 7n. Same difference. And then that's not what they wanted from me, though. They didn't want the general term. I got that so that I could quickly get to the 11th term. So a of 11 would be negative 5 plus 7 times 11, okay, which is negative 5 plus 77, which is equal to positive 72. So a sub 11 is equal to 72. So find that general term. By doing that, then you can find the 11th term. All right, so moving on to the next part, I believe it's got to be an on your own. Correct. All right, so give that on your own a shot. Please hit that pause button yet again. Okay, see if you can't get this one correct. All right, hopefully you did this one by yourself. Here we go. Let's give it a try. I want to find the 9th term of the arithmetic sequence whose first 3 terms are 3, 9, and 15. Okay, so a sub 1 is 3, and then 9, and then 15. So they told me it's arithmetic, so I know it's going to be increasing by plus something or minus something. So 3 to 9 is 6, 9 to 15 is also 6, so that gives me an A1 value of 3 and a D value of 6. Plug that into our formula. So A sub n is the first term plus n minus 1 times that difference. Okay, plug your stuff in. A sub n is 3 plus n minus 1 times my difference, which is 6. Distribute 6n minus 6. So we get negative 3 plus 6n. So there's that general term, but that's not what they asked for. They wanted the 9th term. Okay, they wanted the 9th term, so a sub 9 is negative 3 plus 6 times 9. Okay, 6 times 9 is 54 minus 3 is just 51. So a sub 9. So the 9th term is 51. Okay, hopefully you got that right. Again, you can always go back, try it again, see if you can get it right the second time. Go back through the instruction if you're not understanding. Okay, always have tutoring. You can always come there too if this isn't working out for you. All right, so example 4. If the 3rd term, now here this is a little different. All the other one, they gave me the first 3, so they gave me the 1st, 2nd, and 3rd term. Now they haven't. Okay, if the 3rd term of the arithmetic sequence is 12, and the 8th term is 27, find the 5th term. Okay, a little bit harder. So they gave me the 3rd term. They also gave me the 8th term. Okay, they want to know the 5th term. Well, first I have to figure out what my common difference is. They told me it's arithmetic, so there is a common difference. So from 12 to 27 is 15. Okay, but that's not 15 from 3 to 4. That's not an exact. All of this is 1 to 2. I had a difference of 6. Okay, then from 2 to 3 I had a difference of 6. This is 15 from 3 to 8. Okay, so 8 minus 3 is going to be 5. So the difference of 15 spreads across 5 different numbers. So 15 over 5, this number over the distance here, is going to give me my common difference. Okay, I'll say that one more time. Give me just a second to write that down. Okay, so this is going to be my common difference. So I found first, and this is because I'm not on number 1 and I'm not looking at 3 and 4 or 4 and 5. Okay, I want to know the difference between each number, not across the whole thing. So I first start by doing, okay, so from 3 to 8, there's a difference of 15. Okay, because 12 to 27 gives me 15. But the difference in numbers here was 5. 8 minus 3 is 5. Okay, so I went 5 numbers and covered 15. Okay, I went 5 n values, I guess, and covered 15. So if I divide that out, that means I would go up 3 each time. Okay, so from there, 2 ways you can go about it, and a lot of people are just going to count. If I know that my third, if a sub 3 is 12, well then a sub 4 is going to be 12 plus 3, okay, because that's going to be my next one. And then a sub 5 is just 15 plus 3, which is going to be 18. 15 because that number drops back. Okay, so a sub 5 would be 18. Okay, the other way you could go about that is I could have used my common difference, but then I would have had to go backwards to get my a sub 1. So from a sub 3, I would have to subtract 3. So I would get a sub 2 is 9, and a sub 1 would be 6. So that would actually be my starting point, because if I added 6 plus 3 is 9, plus 3 is 12, so that would take me to there. Okay, so then I could use that in my formula. So either way you want to go, most of you are going to go this way, so that's why I'm not even going to kind of go full-fledged into the other one. Because I could very easily count from the third number to the fifth number. That's not really a big jump. And now if they wanted like the 37th number, then yes, we would absolutely do the general term and then move on from there. All right, so here's your on your own. Definitely do this one. They can get a little confusing. Make sure you keep make sure you keep it straight what you're trying to look at. Okay, so it makes a big difference on whether you're looking at the first term, the 6th term, the 8th term, the 12th term. That makes a big difference. Hit pause, try it, come back, see if you get the same answer as me. It'll be fun for me. Okay, so it's the third term in an arithmetic sequence. There's that word again, okay, over and over again. So they're telling me it's going to be increasing by the same number. It's 23, and the 8th term is 63. Find the 6th term. Okay, so third term is 23. 8th term is 63. Okay, so you just find the difference here, 63 minus 23, which is going to be 40. And the difference here, 8 minus 3, which is going to be 5. Okay, so you're going to get this over this. That's all that's happening. So you get 40 over 5 is going to be your D value, your common difference. Okay, but I'm not going to leave it as 40 over 5 because 5 goes into 40 nice and evenly, so 5 goes into 40 8 times. Okay, so my D value, my common difference is 8, so they want me to find the 6th term. Well, I've got the 3rd term and the 8th term. Again, I can either count up from 3 or I can count down from 8. You take your pick. So if a sub 3 is 23, a sub 4 is 23 plus 8, which is going to be 31. Makes a sub 5 31 plus 8, which is going to be 39. And that makes a sub 6 39 plus 8, which is going to be 47. Okay, so a sub 6 is equal to 47. That's the 6th term. That's what we were looking for. Okay, again, I could have also gone from 63 and subtracted 8 and subtracted 8 to get down to the 6th term. Take your pick. Either way works. Doesn't matter to me which way you choose to do it. All right. Again, they're going to throw some word problems at you because we love word problems. Word problems are great. They're more realistic. So Donna had an offer for a job starting at $40,000 per year and guaranteeing her raise of $1,600 a year for the next 5 years. Write the general term for the arithmetic sequence that models Donna's potential annual salaries and find her salary for the 4th year. Okay, so find the salary for the 4th year. So we're going to start by writing the general sequence. Well, $40,000 is my starting, so that's my first one. Is going to be the $40,000 that I start out at. Okay, I know that my increase, my common difference, is $1,600 because that's how much I'm going to increase each and every year. Where n here is going to be my number of years. So use our formula again. A sub n is a sub 1 plus n minus 1 times d. Okay, plug in everything we know. A sub n is 40,000 plus the n minus 1 times 1,600. Okay, so that's going to be 40,000 plus 1,600 n minus 1,600. Last part here, put those two things together. So I'm going to get 38,400. So A sub n is equal to 38,400 plus 1,600 n. So there's my equation. Okay, that's my general form. And then, did they want that? Write the general term, so that was part of the answer. And then find her salary after the 4th year. Okay, so general term we did, find the 4th year. So A sub 4 is just 38,400 plus 1,600 times 4, which hopefully makes sense. So 4 years have gone by, I've gotten $1,600 raise for 4 years. So it's just 1,600 times 4, add that to my original salary. Now the reason why we had to go back a little bit, that's why it's at 38,400, is because that first year when I put in 1, I needed to be 40,000. So when I put in 1, I'm going to add that 1,600, I'm going to end up at the 40,000. So that's why we had to go back a little. Alright, so 38,400 plus 1,600 times 4, which is going to be 44,800. That is not a bad paycheck. It's decent enough. Alright, so 44,800. Okay, it's a decent, it's an okay. Alright, so now we're looking at geometric sequences. Okay, geometric sequences, which are a little bit different. Okay, this one's not a whole lot longer. I know this is kind of a long section because it's a block day, and this is the weird testing week, so the block days are kind of weird anyways. Alright, so a geometric sequence is a sequence in which each term is obtained by multiplying the preceding term by a constant r. The constant r is called the common ratio. Okay, we kind of talked about this on the first day too. Whenever I wanted to double something, okay, if I wanted to multiply it by 2, if I wanted things to double up, then we actually used an exponent, which is what you're going to see happen here. So, for example, 12, 6, 3, 3 halves. Well, if you look at that, it's going in by halves. Half of 12 is 6, half of 6 is 3, half of 3 is 3 halves. Okay, half of 3 halves would be 3/4, and it would continue to go on. Okay, my first term is still the same thing. The first one listed is 12. My common ratio here, it is decreasing by 1/2. So that would be my first term and my common ratio. Now, I'm going to show you again the big way, and then I'm going to show you how to get your general term here. So, write the first 5 terms of a geometric sequence whose first term is 7 and whose common ratio is 2. So first 5 terms, they tell you is geometric. We're starting with 7. So A1 is 7. Okay, well to get to A2, if my common ratio is 2, then we're going to multiply times 2. So 7 times 2 would be 14. So 3 would be 7 times 3. Sorry. Goodness gracious. When I get to the third one, okay, we don't do times 3. That was my fault. It should be 14. You take the second one, multiply it by 2, because my common ratio is 2. So you hit 28. On the fourth term, we would get 28 times 2, because we're going to times 2 by the one before. So 28 times 2 is 56. And A sub 5 would be 56 times 2, which would be 112. 56. It helps if I could write. It's very late in the afternoon. Let me try that again. Okay, 56 times 2, which would be 112. Okay, so again, it is a common ratio of 2, which means I'm going to start with the first number and multiply by 2. Once I get that, I'm going to bring that down, multiply by 2. It's going to double every single time. Okay, so doubling every single time. So my first 5 terms would be 7, 14, 28, and 56. Well, if you look what's happening here, okay, here I multiplied by 2. Here I multiplied by 2 twice, because I multiplied this one by 2 and this one. Here I multiplied by 2 3 times, because I multiplied by 1, 2 for this, and then 3. So every time I'm multiplying by 2 one more time. Okay, so that's why you get the exponents, because every single time I multiply, I'm multiplying by 2 one more time. Okay, so my general term here, a sub n, is the first term times the ratio raised to the n minus 1. Okay, to the n minus 1. Again, the n minus 1 so that we can make sure that our first term doesn't get multiplied by anything. We want our first term to just be the first term. So where a1 is the first term and r is the common ratio. So this is your geometric sequence formula. This makes writing your general terms a whole lot easier. So find the 8th term of the geometric sequence, whose first term is 12, so here's my a sub 1, whose common ratio is 1/2, so r equals 1/2. Plug that stuff in. Okay, so I've got a sub n is equal to a1 r to the n minus 1. I know a sub 1 is 12. I know my r is 1/2. Notice I'm using parentheses because it's a fraction. And I'm going to the n minus 1. Okay, do not change this to 6. Okay, order of operations says I have to do that exponent before I can multiply. So you cannot multiply those together yet. You have to do that exponent first. So you're going to leave it just like this until I use it. So now I want the 8th term is what they asked for. Okay, so let's find the 8th term. A sub 8 is 12 times 1/2 raised to the 8 minus 1. Okay, so that's going to be 12 times 1/2 to the 7th power. Okay, so 7th power, so that's going to be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Okay, and when I multiply those two things together, and you can do the 1/2 to the 7th power in your calculator. Let's make sure I'm correct, because I just tried to do that quickly in my head, and we don't want to make mistakes, right? Make sure you use your parentheses. 1/2 raised to the 7th power is that, but then we're going to have to fraction, so math fraction is 1/128. What do you know? We got it right. Okay, so we get 1/128, and then multiply by that 12. That's going to reduce. Okay, so times 12, we're going to go like that. Do your math fraction again, and you get 3/32, or you could have just recognized that 4 goes into both 12 and 128, and you would have reduced to 3/32 anyways. Okay, so 3/32 is going to be your 8th term. Okay, whole lot easier, because this right here is not something that's easy to just see if you're just looking at the numbers themselves. So formula is going to be super helpful for you here. Now when they're super easy, you can probably go without the formulas, but most of the time you're going to want to use the formula. Alright, hit the pause button, try that on your own there, okay? Try the yo-yo, do it. Alright, hopefully we're coming back now. Find the 7th term of the geometric sequence whose first term is 64. So here's my a sub 1. Common ratio is 1/4. Okay, ready for this? Let's plug this stuff in. I want the 7th term. First I need my common. So a sub n is a1 r to the n minus 1. There's my formula. Okay, I'm going to plug into that. So a sub n is equal to 64 r, don't write r, silly me. Don't write R. We know R. R is 1/4. We just said that. There's my common ratio raised to the n minus 1. Plug in the stuff you know. I know 64 is A1. I know R is 1/4. Okay, I want the 7th term, so I'm going to plug into this for the 7th term. So A sub 7 is equal to 64 times, again, do not multiply those things together because I have to do that exponent first. 1/4. 7 minus 1 is 6. Okay, so 1/4 to the 6th power, that's not 4 times 6, it's 4 to the 6th power. So let's go ahead, we're going to break this out. So 1 divided by 4, okay, raised to the 6th power, math fraction. One second, I obviously did something wrong there. Alright, so 1/4 raised to the, I was looking for the 7th term, yes. So raised to the 6th power is a really big number, and it's not going to let me do it that way. So I'm going to have to actually just do 4 to the 6th power. So 64, this is actually a good one to look at. So I got this, and I'm not going to work with this. So I'm actually going to do 4 to the 6th power, which is 4,096. So 1 over 4,096. Okay, and then we're just going to hope that 64 goes into it, because we're going to multiply 1 over that number, 4096. Should have used my parentheses, goodness gracious. So parentheses, 1 over 4,096 times 64. Okay, and now let's math fraction that. That should work out very nicely to 1 over 64. So A7 is 1 over 64. So I do want to point that out one more time. When I did the first 1/4 to the 6th power, I got some crazy looking thing. I do not want to work with that. I don't like working with that, so instead I'm going to actually work with the fraction. 4 to the 6th power is 4,096, so I get 1 over 4,096, which I went ahead and then multiplied by my 64. Okay, and then did my math fraction to get 1 over 64. So there's your 7th term. Okay, hopefully you got that. Maybe you got stuck on that awesome little decimal that they threw at you. Okay, but hopefully you got there, or at least understand how to get there. Alright, so now find the 5th term of the geometric series sequence, whose first 3 terms are 2, -6, and 18. So here we go again where they give us the numbers. So in order to figure out what, they give us the first 3 terms. So in order to find the 5th term, we need to figure out what that common ratio is. And we can then either find the general term, or we can just kind of add it or multiply it in this particular case. So if A1 is 2, A2 is -6, and A3 is positive 18. Okay, a few things that you need to kind of see. One is that I've got this alternating signs here. So from here to here, it's still times -3. From here to here, it's times -3, because -6 times -3 is positive 18. And I went straight to times because they said it was geometric, so I know it's going to be multiplying. Okay, so this thing is times -3 and times -3. So R is -3 and A1 is positive 2. Now from there you can either keep multiplying or you can use your formula. I'm going to use the formula because I think it's easier than trying to do it over and over again. Okay, because they want the 5th term. Although I could just go from here and do times -3 and times -3. I'm going to do the formula just because. So A sub n, A1, R to the n minus 1. So A sub n is 2 times -3 to the n minus 1. Okay, so there's my formula, and they want the 5th term. So A sub 5 is 2 times -3 to the 5 minus 1, which is 2 times -3 to the 4th power. Okay, -3 to the 4th power is positive 81. So 2 times 81 is going to be 162. Okay, so the fifth one is 162. So the big part is just figuring out what that common ratio is, which shouldn't be a big deal. Alright, so last little page for this section, just this section. Okay, find the fifth term of the geometric sequence whose first three terms are -3, 6, and -12. This isn't on your own, so hit that pause button, give it a try, come back, we'll do this one, and then we'll finish up those last two examples. Alright, so find the fifth term of the geometric series whose first three terms are -3, 6, and -12. So from here to here, it's geometric, so I know I'm multiplying. So -3 times 6 would be 9 times -2. Okay? 6 to -12 would be times -2. So we're multiplying by -2. That's what's happening. Oops, you can't even see anything I'm doing. Let's try that again. Okay, so -3 to 6 times -2. 6 to -12 times -2. So that's what I'm looking at. I'm multiplying by a -2. Okay, so my formula, I've got A sub n is equal to A sub 1 r to the n minus 1. Well, they said this is my first three terms, so this makes this my first term, is -3. So just plug that stuff in. Okay, so we get -3 times -2 to the n minus 1. They wanted the fifth term, so let's plug that in. A sub n is equal to -3 times -2 to the 5 minus 1. So -3 times -2 to the fourth. Okay, -2 times -2 is +4, times -2 is -8, times -2 is +16. So you get -3 times +16 is your A sub, I wrote n, but it should have said 5. A sub 5, which means that A sub 5 should be -48. Okay, hopefully you got that. So now we can do the same thing too. These have all been 1, 2, and 3. They've given you the first three terms or four terms. Now we're going to jump around. They're going to give me second and sixth or something like that. Okay, so if the second term of this geometric sequence, so A sub 2, is 5/4, and the third term is 5/16, find the first term and the common ratio. Okay, so now they give me 2 and 3. Well, that's kind of nice because it's just going to be 1 over here. But I'm going to have to divide. I know, horrible, horrible word, right? So 5/16, because to get there we'd have to multiply. So to go backwards we need to divide. So if I did, we're going to divide here. So 5/16 divided by 5/4. Okay, remember, keep it, flip it, change it. You can also do this on your calculator if you just really have to. Okay, but it shouldn't be too bad. 1 and 4. So I get 1 over 4. That would be my common ratio. Okay, because this went from 2 to 3, so that was a perfect little mix, 2 to 3. Okay, if it went from 2 to 7, that'd be a little bit different. Then you'd have to divide on that side as well. Okay, so now they want me to find the first term. Okay, well, the first term, same sort of idea. If I want to find the first term from the second, we're going to have to divide to go backwards. Okay, divide to go backwards. Divide to go back. So to find the first term, that A sub 1 is going to be 5/4 divided by our ratio. Okay, multiply to go forward, divide to go back. Okay, so again, we're going to keep it, flip it, change it. And I get 5. Okay, notice that I have 5 here. So if I did 5 times 1/4, I would get 5/4. Okay, so it does work. A sub 1, I do, when I go forward, I multiply, and I'd end up at 5/4. So there's my first one. So R is 1/4, that was part of it. And A sub 1 equals 5, that was the other part. So first term and the common ratio, we did it. Alright, do the on your own. Really try these, make sure you understand them. Okay, come back, make sure you got the right answer. Here we go. If the second term of a geometric sequence is 9 over 2, so A sub 2 is 9/2. And the third term is 27 over 4. find the first term and the common ratio. So to find the common ratio, you just divide. Okay, we are just going to divide. So we're going to start here, and you go this way, divide. So 27/4 divided by 9/2. Okay, or you can figure out what you have to multiply 9/2 from to get 27/4. It works the same way. Okay, so 27/4 times 2/9. 1, 2, 9 goes into 27 3 times, so I end up with 3/2 is my common ratio. Okay, that was all for my common ratio, so this is R. And then find the first term. So to go from the second term to the first term, we divide. So A1 is going to be the second term divided by the first term. So again, we keep it, flip it, change it. So 9/2 times 2/3, you get 1 and 1, you get 1 and 3, so 3. So A sub 1 is 3. Check it. If I multiply this A1 by 3/2, I would get 9/2. Okay, and that's my second term, so that's what I'm supposed to get. So there's A1 and R. Very last one of this little section, which is awesome. It's kind of been a long one, I know. So the popular size of a bacterial culture growing under controlled conditions is doubling. Okay, it is doubling each day. Predict how large the culture will be at the beginning of day 7 if it measures 10 units at the beginning of day 1. Oh goodness, oh goodness. So it is doubling. Okay, doubling means this thing is geometric. It's multiplying. Okay, if it's multiplying, it's geometric, so it is multiplying. Okay, so I have to figure out, to write a formula, I need A1 and I need my R value. Okay, well, they tell us this. This is R. Okay, so R is 2. It is doubling. Okay, R is 2 because it's doubling. They also tell us our starting point. Okay, predict how the culture will be at the beginning of day 7 if it measures 10 at the beginning of day 1. So A1 here is just going to be 10. Okay, so A1 is 10, and my ratio is going to be 2. Plug that in. So A sub n is going to be 10 times 2 raised to the n minus 1. Well, n is the number of days. Okay, so they want to know at the beginning of day 7. A sub 7 is 10 times 2 to the 7 minus 1. Big part of this is recognizing that since it's doubling, it's got to be geometric. Okay, we don't plus 2 to double things, we times 2 to double things. So since it's doubling, it's got to be a geometric. So let's finish this off. 2 to the 6th power is something that I don't feel like doing at this moment. 2 to the 6th power is 64, so I get 10 times 64, which is going to be 640. So it will be 640 units at the beginning of day 7. Okay, 640 units at the beginning of day 7. And that is the end of arithmetic and geometric sequences. Okay, good luck with that homework. Do your homework, that would be awesome. Thanks.